questions 21 through 25 of the 2001 grade 10 Cayley math contest. The point P is on the line y is equal to 5x plus 3. The coordinates of the point Q are 3, -2. If M is the midpoint of PQ, then M must lie on the line. So let's draw a little graph for ourselves and see what this question is all about. So we've got x here, y here, and we've got this line y is equal to 5x plus 3. So it's probably going to be something like this, something like that. And we'll label this y is equal to 5x plus 3. And on this line is a point P. I have no idea where this point P is, so I'll just label it right here. P. Could be anywhere on that line. Then they've given us an additional point, 3, -2. So 3, 1, 2, 3. So this one is going to be our Q. 3, -2 approximately there. And they're saying that you are going to connect those two to create a PQ like this. And M is the midpoint of that. So M will be approximately, I guess, here. It's the midpoint. So that's M. All right? And they want you to figure out M must lie on the line. So what is the equation of this line approximately? Okay, so that is the question. Hope you understand it. So P, the coordinates of P we don't know, right? But because P is on this line, its coordinates will have the form x, 5x plus 3, right? Because the coordinates are normally xy, but y is equal to 5x plus 3. And that's pretty much all we have. So if M is the midpoint right there, we can figure out approximately what M looks like using our midpoint formula. You remember how to figure out the midpoint of 2 points. So this is the first point, this is the second point. You add the coordinates and you divide by 2. So M is going to have some sort of a coordinate here. So I'll call it, whatever you want to call it, x1, y1, right? I think that should be good enough. So now let's figure out the midpoint. So we have 3 plus x divided by 2, right? This 3 there and that x there. And that is our first coordinate. The second coordinate would be -2 plus 5x plus 3. This -2 and that 5x plus 3 divided by 2. And that is M, which we have called x1, y1, like that. Okay, so I hope that makes sense. So therefore, x1 is equal to 3 plus x over 2, and y1 is equal to -2 plus 5x plus 3 over 2. All right, so let's solve for x in both of these. In the first one, we get 2x1 is equal to 3 plus x, and therefore x is equal to 2x1 minus 3. In the second one, we would get 2y1 is equal to 5x plus 1, and this would be 2y1 minus 1 is 5x, and therefore x is equal to 2y1 minus 1 over 5. So from the first one we got x is equal to 2x1 minus 3, and from the second one we got x is equal to 2y1 minus 1 over 5. All right, so those are equal to each other, correct? X, we basically figured out two values for x, so we can set them equal to each other. 2x1 minus 3 is equal to 2y1 minus 1 over 5, like that. Now let's solve for this. Cross multiply and you get 10x1 minus 15 is equal to 2y1 minus 1. And let's see here, 2y1, 10x1, add 1 to both sides and you get minus 14. And if you divide all the expressions by 2, you'd get y1 is equal to 5x1 minus 7. So this is our relationship. This is what m is most likely on a line that looks like this. y1 is equal to 5x1 minus 7. And which of the answer choices is that? Let's see here. It looks like this one, E. 5x minus 7. Yeah, I just have slightly different variables, but E would match what we have calculated. So 21, the answer is E. What is the shortest distance between two circles, the first having center A 5, 3 and radius 12, and the other having center 2, minus 1 and radius 6? Okay, so let's draw this out. So the first thing I did was I just drew a graph, and this is basically the XY plane, and I have labeled the centers. So the first center is A 5, 3 and the second center is B 2, negative 1. Now I'm going to draw circles, the first one having a radius of 12 and the second one having a radius of 6. Okay, so I've drawn two circles, and this is not drawn to scale, but it's okay. We can work with this. So let's label the things now. We've got, this is the radius of the first circle, so I'll draw a line from there to there. And that smaller circle has a radius of 6. So we'll write that in there, 6, right there. And then continuing with the same kind of principle, I'm going to draw the radius from this center to there, like that. Now, if I draw it continuously, it will meet the other circle like that, and if I keep going, it will meet the outside like that. So let's carefully label this. So from this center right here to the very end, right there, that is 12, correct? So we have to somehow, without making this diagram too messy, put that in there. So that distance is 12, okay? And then the radius of the smaller circle is from here to here, all right? And that distance we can label is 6. And I think I already did label that 6, but I did it for a sort of a different position. But that's fine. Now we need to figure out the shortest distance between those two circles, and that would mean this part right here. That part that I put in orange. That would, if this diagram was perfectly drawn to scale, that is the shortest distance between the two circles. Shortest distance between any 2 points is a straight line. Now, how do we figure that out? Well, we know that from here to here is 6. If we can somehow figure out from there to there, we can subtract all that from 12. And the good news is we can. We can find the distance from here to here. How? The distance between those 2 points. So that's where the distance formula comes in. Distance between 2 points, 5 minus 2, right? This 5 and that 2. All squared. So 3 minus 1 is 3 plus 1. And you take the square root. So this looks like 5 minus 2 is 3. 3 squared is 9. 3 plus 1 is 4. 4 squared is 16. And the square root of 9 plus 16 is the square root of 25, which is equal to 5. So this distance right here, from this point to that point, is equal to 5. So now we can figure out this final distance, which I will color one last time. It's the whole distance from there to there, which is 12, minus 5 minus 6. So you have 12 minus 5 minus 6, which is equal to 1. So this distance is 1. And that's the shortest distance between those two circles. So 22 is A. The next two questions on this exam are 23 and 24. And I'm going to solve them in the next few minutes. But they're labeled 24 and 25, so don't get confused by that. A sealed bottle which contains water has been constructed by attaching a cylinder of radius 1 to a cylinder of radius 3 centimeters as shown in figure A. When the bottle is right side up, the height of the water inside is 20 centimeters, as shown in the cross section of the bottle in figure B. When the bottle is upside down, the height of the liquid is 28 centimeters, as shown in figure C. What is the total height in centimeters of the bottle? Okay. All right, so here we go. Where do we start? Well, I think the first thing we can do is first figure out what is it that they're trying us to solve. So what I've done is I've drawn a little bit of a diagram on the side there, and I'll just label it very briefly. This part here, from here to here, I will call H, big H. And this part from here, top to bottom, I will call little h. What they want us to figure out is the total height. So they want us to find big H plus little h. All right? That is what they want us to find in the question. And therefore, we can proceed from there. Now, I'm going to blow this up a little bit here, just so that you get an understanding. And then I can always bring it back down. I just don't want you to have to squint to see what I have to write here. Now, I'm going to label these, so you're going to have to just bear with me. From here to here is H, and we already labeled that, big H. Okay? From here to here is small h, right there. And then this little guy in here, right here, this little guy right there, I hope you can see it in red, that I'm going to call X. Okay? Because this 20 all the way from top to bottom is not from there to there. I almost missed that because, you know, if you don't look closely enough, you think, oh yeah, that's just this H. No, no, no. It's from the bottom all the way to the top right there. Okay? So really quickly, that 20 is basically H plus X. Okay? And then I also have to label one more, which is right here. That. So that is H minus X. Okay? And in a very similar way, I'm going to label the other one. Let's see what we have here. From here to here, it's the same. You're just flipping it upside down. So that is going to be H from all the way from there to there. This little guy up here, that distance right there, I'm going to label Y. Probably do it on the other side there. Y. And therefore, from here to here, has to be h minus y. And from here to here is small h. And I think that completes the labeling of the diagram. So I can squeeze this back down and fit in everything. All right, great. So now that we labeled our diagram, let's calculate the volumes. Figure B, figure C. Volume of figure B is pi r squared times height for the big part plus pi r squared times height for the little part. And what is the two parts? If you draw a line there, the big part is this one and the small part is that one. Basically, you break it up into two rectangles. So I hope you can see that. Maybe I'll blow it up a little bit. So basically, if you draw a line across, the big part is there and the small part is there. Okay? So let's solve for this here. So we have pi r, the big R they tell you is 3. So 3 squared. H, of course, we don't know yet. The little r is 1. So that's 1 squared. And the small h we don't know yet. But we did label the small height x. See, it's right there. So I'll call that x. So this becomes 9 pi h plus pi x. All right. Now we get to figure C, sorry. We just did figure B. So now the volume of figure C. Very similar. Again, you're going to cut it into two parts, and that will allow us to figure out the volume. So pi r squared plus pi r little guy squared times h, like that. Pi r squared big H, pi r squared little h. So the big R is 3 again. And then we've got h, but in this case, be careful now. Our height is not that. Our height is from here to here, right? So it's h minus y. So don't get confused. Just look at the diagram very carefully. And then we got pi small r, which is 1. And h in this case is indeed the full small h, top to bottom. So there you go. That's the correct way of writing that one. So this becomes 9 pi h minus y plus pi h. And that's it. And I think that should be it, because this is the same as this, right? These figure B and figure C are the same. The only difference is that they're flipped upside down. So the amount of water in figure B is the same as the amount of water in figure C. So that means that VB is the same as VC. And we can now equate them. 9 pi h plus pi x is equal to 9 pi h minus y plus pi h. All right, so this is what we're going to use to figure out what we need. And before we do that, there's a couple things that, of course, are pretty obvious, and that is that the big H plus x, they've told you, right, is 20. And I think I mentioned that too earlier. I said be careful. Don't think that h is equal to 20. 20 is actually big H plus x. So I'm going to write that over here. 20 is equal to big H plus x. Any other relationships? Well, yeah, well, figure C has got to give us a relationships for 28, right? 28 equals something. It equals what? Our small h plus big H minus y, right? Yeah, exactly. All right, that's all the information we need to go ahead and figure this out. So we're going to proceed with this equation. So here we go. So we got 9 pi h plus pi x is equal to 9 pi h minus y plus pi h. All right. Does anything cancel? Yeah, the pi's all go. Okay, that's great. So the pi's all disappear. You can just divide both sides by pi. All right, great. Now at this point, we most likely are going to have to substitute because we have too many variables here. So for this big H, I'm going to use this one here. It will be 20 minus x, right? 20 minus x, like that. Plus x is equal to 9. H minus y. H minus y. I'm going to use this one. H minus y is going to be 28 minus h. If you just manipulate that one. And that's it. Okay. We are getting somewhere here, I think. So this one is 180 minus 9x plus x is equal to 252 minus 9h plus h. So 252 minus 180 is 72. Let's see here. This becomes minus 8x. This over here is minus 8h. Bring it over and it becomes 8h like this. Factor out an 8 and you'll get x minus h is equal to 9. Okay, x minus h is equal to 9. And therefore, h minus 9 is equal to x. And what I can then do at this point is substitute this into this one right here. And I hope that helps us. So 20 is equal to x, h plus x. And therefore, h is equal, 20 is equal to h plus h minus 9. And therefore, h plus h is equal to 29. All right, great. And that, if you remember, was what they wanted us to figure out. Find big H plus little h. Big H right here plus little h. And we did that. We got it to be 29. So the answer to number 24 is A. A palindrome is a positive integer whose digits are the same when read forwards or backwards. For example, 2882 is a 4-digit palindrome. 49194 is a 5-digit palindrome. There are pairs of 4-digit palindromes whose sum is a 5-digit palindrome. One such pair is 2889 and 9339. How many such pairs are there? Okay, so first let's understand this question before we proceed with it. They are saying that you have a pair of palindromes that are each 4-digit numbers, 2882 and 9339. So individually, each of these are 4-digit palindromes. And when you add them, which in this case is 12221, this also becomes a palindrome, but this time it's a 5-digit palindrome. Okay? And that is the explanation and the example. And this is one such pair. They want you to figure out how many such pairs are there. So pairs of two numbers where each of the numbers are palindromes and are 4 digits, when added, will result in a 5-digit number that is also a palindrome. Okay? So what we will do initially is use some letters to describe or represent each palindrome that's 4 digits. The first one I'll call A, B, B, A, and C, D, D, C. And when you add them up, they will give a 5-digit palindrome. So I will call it G, E, F, E, G, like that, okay? And we don't know what these letters are, but this is just a representation. Now let's try to figure out some clues here as to what this possibly could be in terms of numbers. The largest possible 4-digit number is 9999, correct? And interestingly, that's also a palindrome. So if you add two of them, very similar to what I did up there, you would get a sum of 19998. So this is the maximum sum of two 4-digit numbers. So therefore, the maximum value for this first digit is a 1. You can never get anything greater than a 1. Can you get a 0? Well, you can, but if you put 0 there, it's not a 5-digit number anymore. We want a 5-digit number, a 5-digit number that's a palindrome. So that basically means that this G is a 1. That's the only way this can work. So that becomes a 1, like that. And therefore, this G is a 1. Okay? So that's the first part of our question. We're going to slowly try to systematically figure out all the possible numbers. Now, before we create an algebraic equation, we need to look at this column right here. Based on simple addition, A plus C, it should equal 1, correct? All right, possible. But if that's the case, then what about this guy right here? That A plus C would also equal 1. But if that's the case, then this guy doesn't need to be there. It would become a 4-digit number. So A plus C equal to 1 is probably not going to work. Okay? So then we say, well, then how is this going to work here if A plus C is not 1? Well, A plus C could equal 11, right? Because if it equals 11, you put the 1 down there and you carry the 1 based on simple addition. And that is the only way this is going to work. It must be that A plus C is equal to 11. All right? That's the only way you can produce a 5-digit number, which hopefully will then be a palindrome. Okay? So that is the first part of the question, and now we proceed to the second part. The second part of the question basically involves we have to now use this and write it all out as if it was an actual number. Right now it's just letters, right? So the first part, ABBA, what is that really? It's 1,000 times A, the first digit, plus 100 times B, plus 10 times B, plus A. Correct? And you are adding to that number, which is very similarly 1,000 times C, plus 100 times D, plus 10 times D, plus C. And that equals this number, which is 10,000 plus 1,000 E plus 100 F plus 10 E plus 1. Okay? So that is how this is all written out. And this guy is a 5-digit palindrome, or it must be. That's what we are trying to figure out. Okay, let's move forward with this here. I'll keep this. That should be good enough. All right, so here we go. Let's add all this as much as we can. The A's become 1001A. The B's, we got 110B. What else do we have here? We have the C's is 1001C plus 110D. And this whole thing is our 5-digit palindrome, like that. We are concerned really with trying to figure out A, B, C, D, and E, like that. So on the left side, the 1001 we can probably factor A plus C, and the 110 we can factor B plus D, like that. And the right side is our 5-digit palindrome. Okay? So hopefully so far you're not lost. Now this is where the magic comes in. A plus C we have determined must be 11. So we can put that in there. 1001 is 11 plus 110 plus B plus D, like that. And therefore this becomes 11011 plus 110 B plus D is equal to a palindrome. And that's about as far as we can go there. So now at this point, we've got to figure out a table here. We've got 11011 and we have B plus D. If we choose different values, what will be the result? The result has to be a 5-digit palindrome. Okay? So let's see what we get. And first of all, B plus D, B and D are digits, right? So the lowest possible sum is 0 and 0. So that's 0 plus 0, like that, which would be 0. And the highest possible sum, if both of them were 9s. So 9 plus 9, which is 18. And we have to figure out the value of this for each of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Great, fit them all in. All right, let's go with this now. So when it's 0, it just becomes 11011. Is this result a 5-digit palindrome, which is what we want? And the answer is yes. So great, we got our first scenario here. B plus D is equal to 0. And if we keep going, the math in this is pretty straightforward. You're just adding 110 each time. So it shouldn't be that hard. So this is going to be 1, 1, 1, 2, 1, 1, 1, 3, 1, 1, 2, 3, 1, 1, 1, 3, 4, 1, and so on. So we got 1, 1, 4, 5, 1, and I'll fill them all in. So there you have it. Those are all the numbers. So how many of these result in a palindrome? Well, let's see. Let's look down the list. And it looks like the only one is this one here. All the others are not palindromes. So we get a palindrome when B plus D is equal to 0 and when B plus D is equal to 11. So great, we have B plus D, but we have to figure out also A and C, right? Those numbers, that pair, are not just B and D, they involve an A and a C. So now our next step is to figure out A and C, but we know that A plus C is equal to 11, so that should definitely help us out. So remember, we've got two scenarios, B plus D is equal to 0 and B plus D is equal to 11. So now we must figure out values of A and C. A and C, will make a little table. We know that A plus C is equal to 11, right? So that is definitely going to help us. And we have only two scenarios for B plus D. We have B plus D equal to 0 and B plus D is equal to, if you remember, 11. These two scenarios right there. B plus D is equal to 11, like that. Okay, let's proceed with this table. So A plus C is equal to 11, right? So A, for example, can be 1 and C can be 10, correct? No, because they have to be digits. So that's wrong. A can be 2 and C can be 9, correct? Yes. Is A plus C is 11 in this case? Yep. And B plus D is equal to 0? All right. That's fine. So that's one possibility, right? And that I'll put the possibilities in brackets like that. I just don't want to get this too confusing. Now, before I continue, I want you to understand what just happened here. Right? You think, okay, you got all these letters. We've created two palindromes. Remember our palindromes were A, B, B, A, and C, D, D, C, right? All the way at the very beginning, right here. A, B, B, A, and C, D, D, C, correct? So we created two. And we created the ones as follows. For A, B, B, A, let's see, and B and D equals 0, so that means B is 0 and D is 0. That's the only way this will work, right? Because you can't have negative numbers. You can't have 4, negative 2, 6, 1. That's not a number. So what numbers did we create with A equal to 2, C equal to 9, B equal to 0, and D equal to 0? Well, let's see here. We got 2, 0, 0, 2, and 9, 0, 0, 9. These are indeed two 4-digit palindromes, correct? And if I add them, I hope that I get a 5-digit palindrome. And I do. I get this one. So this is what I created. A pair. A pair of two 4-digit palindromes whose sum is a 5-digit palindrome. Okay? Let's keep going here. So for A, we got 3, 8. This checks out. This would give me one more scenario. Okay, and you can write them all out. What else do we got? 4, 7, 5, 6, 6, 5, 7, 4, 8, 3, and 9, 2. For each of these of course will all check out, and for each of these it'll be exactly the same. B is 0, D is 0, and each of these will give us one scenario, one pair. It's better to call it a pair than a scenario. So how many do I have total? I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 pairs. Okay, so what are our answer choices, just out of curiosity here? How many do they say? Ooh, 28, 32, 36, 40, and 44. Okay, I got quite a few more. Oh boy. All right, no problem. But so far you're understanding, right? Now, the only other scenario, the good news is B plus D is equal to 11. Okay, that's it. But B plus D equals to 11, unfortunately, is not as simple as when B plus D equaled 0. In this case, we're going to have a little bit more to figure out. So if B plus D is equal to 11, we've got quite a few scenarios. We've got B and D, let's say, I'll put it here on the side. B and D. We have 2, 9, 3, 8. I hope this looks familiar. 4, 7, 5, 6, 6, 5, 7, 4, 8, 3, and 9, 2. So for each of these, for example, when A is 2 and C is 9, each of these is going to give 1, 2, 3, 4, 5, 6, 7, 8 possibilities for B plus D is equal to 11. See what I mean? You just have to take all of these and throw it into there. I hope that makes sense. And very similarly, for each pair of A and C, like that, you're going to have 8 possibilities. So this will give you 8 pairs, this will give you 8 pairs, This will give you 8, and so on, like that. So just to help you understand, if let's say you had A is 2 and C is 9 and B is 2 and D is 9, what would be our numbers? I'll draw it down here. A, B, B, A, and C, D, D, C. It would be 2, 2, 2, 2, and then C is 9, right? So 9, 9, and then what is D? 9. So this is our pair. 2 4-digit palindromes that have a sum, which is a 5-digit palindrome. And similarly, you can do the same for B is 3, D is 8, B is 4, D is 7, like that. All right. So now, finally, let's total it all up. All of these. These are all the pairs. So we got 1, 2, 3, 4, 5, 6, 7, 8. 8 times 8 plus 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1. And this looks like 8 plus 64, which is 72. All right, let's go back and see if 72 is one of the answers. And it is not. Oh. Well, that means we double counted then, because I saw 36 in there. Yeah, I saw 36 in there. Oh, okay. We double counted. All right, no problem. Now you might say, oh boy, what do you mean by that, double counted? Well, I'll explain. So for example, let's just choose one of these guys here. AC, choose this one here. A and C is 4 and 7, and B and D, you can choose, doesn't really matter, 6, 5, right? So A is 4, C is 7, B is 6, and D is 5, right? I'm just giving an example to illustrate why we double counted. If you chose these numbers, what would be our two palindromes, our two 4-digit palindromes? They would be 4, 6, 6, 4 and 7, 5, 5, 7, right? And the sum is 1, 2, 2, 2, 1, like that. Now, let's say we chose A is equal to 7 and C is equal to 4 and B is equal to 5 and D is equal to 6. What would be our palindromes for A, B, B, A, and C, D, D, C? Well, we'd have, let's see here, 7, 5, 5, 7 and 4, 6, 6, 4. And the sum would be 1, 2, 2, 1. But notice this pair is the same as this pair. It's the same pair. So we double counted. You see, I hope that makes sense. So therefore, this 72 is listing a set of pairs twice. So to get the number of unique pairs, you have to divide by 2. So I wrote it out. 72 is twice the number of unique pairs. Number of unique pairs is 72 divided by 2, which is 36. And therefore, the answer is 36, which is C. The circle with center A has radius 3 and is tangent to both the positive x-axis and positive y-axis as shown. Also, the circle with center B has radius 1 and is tangent to both the positive x-axis and the circle with center A. The line L is tangent to both circles. The y-intercept of line L is. So let's label this diagram first. First thing I'm going to do is drop a perpendicular from A down to the bottom like that, and the same with B. And then I'll draw lines to the sides, and these all of course represent the radius, like that, and like that. and one continuous line to the very end right there. And I think that should be enough. And if we need any more lines later, we can always add them. Now let's label the distances, what we know. We know that the radius of the large circle is 3. And therefore this is 3, and that's 3. And this is 3, and so on. They're all radii. The radius of the small circle is 1. So this is 1, and this is 1, and this is 1 right here, and this is 1 right there. Now this distance here we don't know, so I'll call it A. And this distance here similarly I don't know, so I'll call that B. And there's one more distance I don't know, and that's this guy right here, this little guy right there. So I'll call that X. I'll label X right there. Okay? So let's work with this. Let's see what we can find. Now the first thing I notice is that we have a similar triangle relationship. We have this triangle, and that triangle is similar to this one, this little one right here. All right? So because those triangles are similar, the ratio of the sides are the same. So in the first one, we've got 3, which is the height, and the hypotenuse, which is 3 plus 1 plus 1 plus x, right? From here to here is 3, then we got 1 plus 1, and then finally that little x there. And then that is equal to the ratio of the height and hypotenuse of the little guy. So 1 over 1 plus x. So 1 over 1 plus x, like that. So let's solve for x now. Cross multiply. We get 3 plus 3x is equal to, this looks like 3 plus 1 plus 1 plus x. So 3 plus 3x is equal to 5 plus x. And if you bring the x over, it becomes 2x, and bring the 3 over, it becomes 2, and therefore x is equal to 1. So there you go. We've got our first value. Now we will proceed. We'll try to find A and B. So let's try to find B first. B is very similar in terms of the similar triangle situation. Again, we're going to use the same triangle as this one and that little guy right there, that one. So we can use very similar relationship. We'll use the relationship of the side and the base. So for the big one, it's 3 over A plus B, like that. 3 over A plus B. And for the small one, it's 1 over B. 1 over B, like that. Okay? So cross multiply, you get 3B is equal to A plus B, and therefore 2B is equal to A. Now B we can easily figure out from this triangle right here using Pythagoras. Right there, that's a right triangle. Because remember, when a circle is tangent, it means that will become a right angle like that. Same thing's true there. So B, if you use Pythagoras, you get 1 squared plus B squared is equal to this hypotenuse, which is 1 plus 1, because we figured out the value for x. So we have 1 squared plus B squared is equal to 1 plus 1 squared. And this is 1 plus B squared is equal to 4, 2 squared. And therefore B squared is equal to 4 minus 1. B squared is equal to 3. So B is equal to root 3. So I can label that in there, root 3. And then coming back to this equation, 2B is equal to A. B we just figured out was root 3. So therefore A is equal to 2 root 3. All right? So far so good. Now what I want to do is blow this up as big as I can and explain something to you. So far, what did we have? We have b is equal to root 3, which is right here, right? And this is 1 from here to here. And this, if you can bring that x in there, is 1 plus 1, which is 2. So we have root 3 as the base, 1 as the height, 2 as the hypotenuse. So if you remember, if you have any triangle that has those relationships, I'll draw a triangle here. So if you have a triangle that has those sides, 1, root 3, and 2, this is a 60, 30, 90 triangle, where this is 30 degrees and this is 60 degrees. This is always true. The ratio of the sides is always going to be 1, 2, and root 3. Not necessarily the side lengths, but the ratio for sure. In this, our example, we happen to have the side lengths also equal to 1, 2, and root 3. But the ratio is always going to be 1, 2, and root 3 for any triangle that has angles 30, 60, 90. So, therefore, this angle in here is 30 degrees. Right there. And therefore, this angle also is going to be 30 degrees. Why? Because these two triangles, this one here and that one there, are identical. They have the same side lengths, they have the same angles. So that is also 30 degrees. Running out of space here. I'll just squeeze it in there, 30 like that. So that means this whole angle, right here, this whole angle is 60 degrees. Okay? So that basically means that you have another 30, 60, 90 triangle. That angle is 60. This angle, of course, is a 90. And by subtraction, you will get that that is 30. Okay? So, what do we want to figure out in our question? We want to figure out the y-intercept of line L. So right here, this is the point. It's a y-intercept, so it will be of the form 0y. And y basically represents the distance all the way down to the origin like that. So that is y. Now how do we figure out y? Well, we have a 30, 60, 90 triangle, correct? And we can use the ratio of the sides. So I'll draw it here without messing up the diagram again. So we have this triangle, and it has the angles 90, 60, and 30. And y is right here. And this part, the base, we have figured out. It's 3 plus a plus b, correct? 3 plus a, which is 2 root 3, plus b, which is root 3. And this is all 3 plus 3 root 3. So now we can use the ratio of the sides, which in a 30, 60, 90 triangle are 1, root 3, and 2. All right? So let's calculate that. So that means that y over the base, which is 3 plus 3 root 3, is equal to the ratios, which is root 3 over 1. So let's solve for this. So this becomes y is equal to root 3 times 3 plus 3 root 3. And this looks like 3 root 3 plus 3 times root 3, which becomes 3 times 3, which is 9. So there you have it. 3 root 3 plus 9. And that would be choice E.